Well, hello. I think I'm shooting a video. We'll see how this works. We're going to work on a problem for completing the square. This is a technique for solving a quadratic. Usually you use it when the quadratic is not factorable. So here's what I'd like you to write down. We're going to write 3x squared plus 4x minus 5 equals 0. So what we have here is we have a second order term. We have an x squared term. There's a 3 in front of that. So whatever x is, we got 3 of the square of x. So that's one thing. Then we're adding to that 4 of whatever x is. And then the whole entire shebang, we're taking away 5, and that's going to equal 0. So what is the magic x that's going to solve this? Well, one of the things to be aware of is there's two x's that are going to solve this. And I don't know if they're both positive or both negative, or one positive and one negative. It'd have to be, I don't know. I haven't got any idea what they are right now. We'll find out. But the point is there's an x squared term. So if x is negative, the x squared term is positive. But there's also an x term, and this thing says plus 4x. So that's going to be adding something no matter what. So if x is positive, 4x is positive. If x is negative, 4x is negative. But if x is positive, 3x squared is positive. And if x is negative, 3x squared is still positive. So that's why there's two solutions, because we got a squared term. So here's what we're going to find these two solutions. First thing to do is to get rid of that 5. That 5 sitting over there doesn't have any x with it at all, and we're trying to find x. So we want to get x by itself. Getting rid of 5 is a good place to start. So let's send it over to the other side. Do that. Now are you looking at an expression that says 3x squared plus 4x equals 5? Sure hope so. Now over on the left side, we've got a 3 and we've got a 4. You might be tempted to want to get rid of that 4 first, because quite frankly, we went with the one that had no x's at all and got rid of it, 5. Maybe we go to the one with only one x and then the one with 2. But this technique works best. I imagine we could probably do the other thing and have some other method, but this one is about getting rid of that leading coefficient, the coefficient on the x squared term. So that 3 is what we want to deal with now. What that 3 is doing, it is a coefficient, so it's multiplying. So in order to get rid of it, we have to do the inverse of multiplication. So, quick moment here, that 5 was sitting there was minus 5, so we did the inverse of subtraction, which was addition, added 5 to both sides. That's how it got on the other side. Now how that 3 is going to go to the other side is we're going to divide everything through by 3. So 3x squared divided by 3 just leaves us with x squared. Plus 4x divided by 3 leaves us with plus 4/3 x. And over on the other side, 5 divided by 3 leaves us with 5/3. So you should have x squared plus 4/3 x equals 5/3. This is where we're going to complete the square. On the left side, we have an x squared plus 4/3 x. And we know that if we are squaring something, an x plus something, and we square it, we're going to get an x squared plus 2 of the something times x plus some other stuff. So that's what we're going to do. We see x squared plus 4/3 x. We're going to write this as a perfect square. We're going to put some parentheses and put an x plus 2/3, close the parentheses, and square that. The reason why we're choosing 2/3 is because 2 of those is going to give us the 4/3 that we're looking at. But right now, we can't write equals 5/3 because it doesn't. Because x plus 2/3 the quantity squared, when you FOIL that, will give you 3 terms instead of just 2. You just have 2 terms sitting there. We have x squared plus 4/3 x. We're going to turn this into x squared plus 2/3, x plus 2/3 the quantity squared. That's adding another term. There's 3 terms there even though you don't see them. So what we're going to do is we're going to add that term to the other side. And that's how we are completing the square, adding that extra term to the other side. If you have x plus 2/3 and you square that, you're going to be squaring 2/3. You're going to get 4/9. So, yeah, that's what you're going to do. So, on the right side, on the left side, you've got open parentheses, x plus 2/3, close parentheses, the quantity squared, or x plus 2/3, the quantity squared. On the right side, you get equals 5/3 plus 4/9. Let's go ahead and do the right side. 5/3 plus 4/9 needs a common denominator. That common denominator is, you betcha it's 9. So you're going to take your 5/3, multiply top and bottom by 3 to give you 15 ninths, right? Add your 4 ninths to that, and you're getting 19 ninths, I think, over on that side. So now what will happen is you've got x plus 2/3 the quantity squared equals 19 ninths. Well, now you've got this 2 over there where x is. So you want to get rid of that. And you get rid of that by doing the inverse of squaring, which is taking a square root. So we'll take the square root of x plus 2/3 squared. Why, that's just going to be x plus 2/3. Then we want to take the square root of the other side, where I think we had 19 ninths. That's going to be the square root of 19 over 3, because you can take the square root of 9. But 19 is a prime number. That square root we're just going to leave with the bracket on it. However, this is where we've got to be clever and realize there are 2 numbers you can square to get 19. There's the positive square root of 19 and the negative square root of 19. Thank heaven somebody invented the plus or minus symbol. So we can write x plus 2/3 equals plus or minus radical 19 all over 3. Move that 2/3 over to the other side, and you get x equals negative 2 plus or minus radical 19 all over 3. And that's how you complete the square. Hopefully that was enjoyable. If it wasn't, well, watch somebody else's video on that, and maybe you'll enjoy yourself then. Let me know if you have any questions. Rock and roll.